Welcome to DA classes. Today we'll explore motion in a plane and vector operations, including addition, subtraction, and multiplication, along with their physical significance. Let's begin by understanding the difference between scalars and vectors. Scalars are quantities that have only magnitude, like mass, temperature, or time. Vectors, on the other hand, have both magnitude and direction, like velocity, force, or displacement. Vectors can be represented graphically as arrows. In a two-dimensional plane, we can describe a vector using two components x and y. For example, this vector has an x component of 3 units and a y component of 4 units. Its magnitude, or length, is 5 units, calculated using the Pythagorean theorem. Now, let's discuss motion in a plane. When an object moves in a two-dimensional plane, we track its position using a position vector. The velocity vector represents the rate of change of position, and the acceleration vector represents the rate of change of velocity. Let's explore vector operations, starting with vector addition. Here, we have vector A and vector B. To add these vectors, we can use the tip-to-tail method, where we place the tail of one vector at the tip of the other. The resultant vector, R, is the sum A plus B. We can also use the parallelogram method for vector addition. We draw a parallelogram with the two vectors as adjacent sides. The diagonal of this parallelogram is the resultant vector. Physically, vector addition is used to find net forces, total displacement, or resultant velocity when multiple vectors act simultaneously. Vector subtraction works similarly. To subtract vector B from vector A, we add vector A and the negative of vector B. The negative of a vector has the same magnitude but opposite direction. So, a minus b gives us this resultant vector. Physically, vector subtraction can represent relative velocity, displacement between 2 points, or the difference between forces. Now, let's look at scalar multiplication. When we multiply a vector by a scalar, we change its magnitude, but keep the same direction if the scalar is positive. If the scalar is negative, the direction is reversed. Physically, scalar multiplication represents scaling physical quantities like doubling a force or having a velocity. Next, let's discuss the dot product, which is a type of vector multiplication that results in a scalar. The dot product of two vectors A and B is defined as the product of their magnitudes and the cosine of the angle between them. It can also be calculated using components. A underscore x times B underscore x plus A underscore x times B underscore y. Physically, the dot product represents work done by a force, power, or the projection of one vector onto another. Finally, let's explore the cross product, which is a vector multiplication that results in another vector. The cross product of vectors A and B is a vector perpendicular to both, with magnitude equal to the product of their magnitudes and the sine of the angle between them. The direction is determined by the right-hand rule. Physically, the cross product represents torque, angular momentum, or the area of a parallelogram formed by two vectors. To summarize, vectors are essential tools for describing motion in a plane and other physical phenomena. We've covered vector addition, subtraction, scalar multiplication, dot product, and cross product, along with their physical significance. Thank you for watching. Please like and subscribe to DA classes for more educational content.